Okay, Bismillahirrahmanirrahim. And previously, we were looking at this topic of clustering, and we covered the fuzzy clustering and we covered the fuzzy k-means or c-means clustering. And fuzzy clustering was the category of what was that? Exclusive clustering, and fuzzy k-means was the category of overlapping clustering. And then we said that we will cover these top two in detail, but the rest of the two, we will not go into the details of that. But we will get the introduction of these two clustering, what these things are. So that's why now we are going to start just the definition or the description, minor description of the hierarchical clustering. So if you will look into this diagram, so initially you will have the data points like single clusters, okay? You will consider each data point like a single cluster. And then you will calculate actually the distance for, if it is clusters, then they have centroids. And then you will calculate distance for all of these clusters. And based on this distance, whatever the two clusters which have the minimum distance, you will merge them. So you will make pairs and then you will merge them. For example, this B and C has the minimum distance. So that's why you are going to merge it like B and C. And similarly, D and E also has the minimum distance. So you are going to merge this D and E. And after that, what is left in your cluster? In your clusters, A is left, B, C is left, D, E left, and F is left. And now you will again, now you have the new clusters, and now you will again calculate the distances. And based on the minimum distance, for example, here, D, E, and F has the minimum distance, so that's why you are merging them. And similarly, so now how many clusters you have? You have A, B, C, and D, E, F. Now you are again calculating distances, and then based on these distances, this B, C, and D, E, F has the minimum, so that's why you are merging them. And finally, only two are left, so that's why now we are merging them directly, and you are getting finally a single cluster. So if you will look into this theoretical algorithm, then it will give you the same concept. So initially, you have the data set, which will have D1, D2, D3, and Dn. You can call them data points or whatever of size n. What you will do, you will calculate the distance matrix. So you will calculate the distance, generally. And here you have the first loop starting from for I is equal to 1 to n is the size of the data set. And then you have another nested loop in it, which is for j is equal to 1 to I. Whatever the value of I is, this j will go up to that point. Up to that point. And there are some comments written here. Because it is a distance matrix, so you will have a two-dimensional matrix here. You will have a two-dimensional matrix here. You will have a two-dimensional matrix here. And when we will have a matrix, then normally what it is saying that we have kept the variables of these loops like that, because if you have the diagonal, you have the same values at the upper portion of the diagonal and also at the lower portion of the diagonal. So that's why we are ignoring the upper portion of the values in the upper portion of the diagonal, and we are taking care of only the values which are lower than this diagonal. So that is what mentioned here. And that is what, due to this reason, you have the loops like that, starting from 1 to n, and the other loop is from 1 to that I. And whenever this I, so when for 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 2, 3, 3, 4, 4, and lower values than that, we are not going to calculate the upper values because it would be the same. So that is what mentioned here. And then here you are doing what? Here you are calculating the distance. There is no formula mentioned here because we are not going into detail of that. So we only want to know the formula would be the same. Maybe, for example, in previous clustering algorithms, you calculated the distances from the centroid to the other data points. So distance di and dj. So I is this one, j is this one. So you will have the points 1 1 and 1 2 and 1 3 or something like that. Only here the lower portion, and these would be the values. And then you will have sometime you will have the same point repeated, and sometime mostly you will have these points different, and then you will calculate the distance. Whatever the distance is, you are storing that distance in a distance matrix with the index I and j, which are these variables. So okay, in this way you are calculating the values. And here and here, each data point is what initially is a singleton cluster. This is what when I was describing, this is what initially you have singleton clusters, single clusters. Then you have this loop has the loop repeat until loop. And this okay repeat, and then initially what you are doing, merging the two clusters having the minimum distance. So this is what, after doing that, you have that all values with all distance values, huh? All values are calculated. Now you are doing what? You have another loop which will compare their distance values, and then it will merge the two clusters having the minimum distance as you are seeing here. As you are seeing here. So these two have the minimum. So that's why we are merging them. And similarly, after that, so you are merging two clusters having the minimum distance, and then you are updating the values of distance matrix again. And in this way, you will go on merging these clusters until you have a single cluster remains at the end. So this is one type of hierarchical clustering, that is agglomerative. I think this hierarchical clustering was already appeared on the previous slides, and there we talked about these two types of uh, hierarchical clustering. So this is what. So here, this is step 1, step 2, step 3, and so on. This is that understanding. And now moving toward the other type is divisive. Other type is divisive. That is the opposite of that previous one. That is the opposite of that previous one. So if that you will look into this theoretical algorithm, so given data set is from D1 to Dn same with the size n. And at the top, we have all the data in one cluster. So what is the initial step? At the top, you have, this is step 1. At the top, you have all the data in one cluster. This is one cluster. This is what? This is single cluster, and you have all the data points A, B, C, D in it. This is what this step is showing. And then you have to split the cluster. And how you can split the cluster using some clustering algorithm. And here you can use k-means. Here you can use k-means, and you already know k-means clustering. So by using that k-means, you can split the clusters. You can split the clusters. And for example, so cluster is split using a flat clustering method. So we have to split, and that is the repetition step in which you are splitting and going up to where until you have all the points as a single cluster. So now in this repeat until loop, you have to choose the best cluster from all these clusters. From all these clusters, you have to choose the best cluster for splitting. So you can use the k-means for splitting. And here we are splitting by using that k-mean B, C, D, and A. A is singleton, but this BCDE is not. So that's why now you will focus on it, and then you will again search for the best cluster to split by using that k-means. And okay, from this, you are getting again BC and DEF by using that K means. And after that, again, because we are executing this repeat until loop. So again, we will select best cluster from this BC. And then after that, you are splitting and you are getting B and C, which are singleton. So you will stop there. And for DEF, you are splitting into DE and F. And then in the next iteration, DE is splitted further into D and E. So you will keep on continuing this loop until you have your data as a single cluster at the end. And that's why it was step one, step two. So this is exactly the same diagram that you have on the previous slide, but only these steps are reversed. So this is the second category of hierarchical clustering algorithms. So now moving next to probabilistic clustering algorithms. We have previously seen a short definition of probabilistic clustering, and we know that in this probabilistic clustering, we will use some kind of a probabilistic theory. And here we are using Gaussian mixture model. Gaussian mixture model. What is Gaussian distribution? Anybody? Just simple answer, general answer. What is Gaussian distribution? Normal distribution. It is normal distribution. So you know the curve of that normal distribution, huh? Like a bell curve. So that is the Gaussian distribution. Okay. So now here in this probabilistic clustering algorithm, theoretically understanding is given here on this slide, not in detail, but theoretical understanding, so that you have an idea that in this probabilistic clustering algorithm, what you can normally do that. So here the step one is mentioned, which is the step of initialization, and then step two, which is the step of estimation, and then step four, or you can call it step three, which is the step of maximization. Normally, when you have the word estimation, that means you are going to calculate the probability here. And when the word is maximization, here you are going to maximize the likelihood, maximize the probability, maximize the log probability. Anyhow, let's see that. What is the initialization of this algorithm? So in initialization, you will have a k number of clusters. K number of clusters from the data set. You will give the value to this k variable. You will give some value, either 10 or 15 or 20, whatever the number of clusters that you want for your data set. So you will give some number to this k variable. That would be your Gaussian distribution. You can also call it k Gaussian distribution. And then there are some other variables in this Gaussian distribution that you have to take care of. And those are the three variables. What are those three variables? First is mean. Mean is a variable there. And mean is represented in the equation of Gaussian distribution. Mean is represented with this gamma. Or I can also call it mu. But gamma is proper term mathematically. So mean has this symbol. And we have the k number of clusters. So that's why we will use k gamma variables from 1 to up to k for each cluster. And similarly, the second variable would be the covariance. In this equation, the second variable would be the covariance. And that variable in this Gaussian distribution or normal distribution, that variable is represented with sigma. And we have the k cluster, so that's why we have k variables here, starting from sigma 1, sigma 2, and so on, sigma k. And the third variable that you have in this Gaussian distribution equation, that is the density distribution. That is the density distribution. The number of points for distribution. And you will represent those points or density distribution with this big pi, this is not small pi, big pi. Pi and I will take the number of the data points, 1, 2, 3, 4, how many it is. Okay, this is the initialization. You will give some random value to these variables. At the initial step, you will give some random value, any value, huh? Any value which is coming in your mind, you can give it to him. But this is initialization. So you should have to give them small values, huh? Step 2, E step, called E step, which means estimation step. And here you will calculate what? Here you will calculate the probability of each data point in your data set. Each data point in your data set. And we are going to represent our data points with this variable xi. xi. So each data point, you are going to calculate the probability of each data point in your data set. And you will calculate the probability of this point with respect to clusters. And how many clusters you have? C1, C2, and Ck. K Gaussian clusters, or K Gaussian components. So if the author has used some different term, don't worry. This is talking about clusters. Because you have to calculate the probability of that data point with respect to that cluster, that the probability, this data point has the probability with that cluster or that cluster or that cluster, huh? So this is what generally you have to find. This is what, if you have K clusters, then here you have to find the probability of each data point in your data set with respect to each cluster. And when you will calculate the probability, normally probability has the equation, normally, for example, probability of y given x, this is the normal general equation. So you have to find the probability of this given this. So then if you have to calculate the probability, then what would be the given? Given would be these parameters, these variables that you already have. What would be the given? What would be the given condition? Given condition would be these three variables that you already have done in the initial step number 1. So that is written here, given the current parameter values. And these parameter values are those three variables. Anyhow, you will calculate the probability of, generally, you will calculate the probability of each data point with respect to each cluster. And that you have K clusters. And then surely you will get, for example, if the data point is x1 and you are calculating probability of x1 with c1, c2, c3, c4, and so on, ck, and these c's are clusters, then you might have this situation that the point x1 has higher probability with the cluster c5 and not too much high value with the C1, C2, C3 or other clusters. But with the C5, it has high value of probability. And if you have high value of that probability, then it means you have to assign this data point to that cluster. Huh? What it means? It means you have to, if you have a high value of some data point, then you have to assign this point to that cluster. And that cluster would be the right candidate for that. And then, okay, now you have calculated the probability and you have assigned the data point to that cluster. When you will do this for all the data points, now what you have to do? You have to go back. You go back means now you don't have to perform this E step. You have to update. You have to update the values of these variables because now data points are shifted towards different clusters. Huh? After this step, data points are shifted, moved towards different clusters according to the probability value. So it means now the mean value that you have taken before, or the covariance value that you have taken before, or the density distribution that you have, how the data points are distributed. So these three things does not have any value now because the points are shifted. So you have to calculate these means, covariance, and pi again. So that's why it is mentioned here, update pi, gamma, and sigma. When it will be updated, now you are again ready. Now you are again ready to calculate the probabilities. Okay, for the new iteration, huh? So that's why now the step number 4, which is called M step, which is maximization step. You have the probability of the data points, but you want to maximize the probability. So that's why you will calculate the new probabilities again by using a similar method. By using a similar method, you will calculate again the new probabilities for each data point. And then you will update the parameter values that previous step. Where is it? Is this one? And then you will update the parameter values again. And you will keep on doing that iteratively. Iteratively, you will keep on doing that iteratively. Why iteratively? Because we want to maximize the log likelihood. Likelihood is probability. Okay, likelihood is probability. And the log of that probability means if you will get something negative, so that would be positive, huh? That so log will give you always positive and higher positive value. When we were discussing logistic regression, at that point we used the log, huh? And we discussed this thing in detail, why we use the log. That is the same reason here. That is the same reason here. So we will do this iteration because we want to maximize the probability. What kind of probability? Log probability. So here you don't have the log, but here you will use the log. That is the only difference. That is the only difference between this step and that step. And in this way, your points will be shifted to different cluster, and on each iteration. On each iteration, you can imagine that your points will be shifted to different clusters. And then it's up to you where you want to reach. Either you can introduce some threshold where you can stop, or you can set some number of iterations that after 1 million iterations, or maybe after 0.1 million iteration, you will stop this algorithm. And then you will plot the data, where the data, what is the situation of the data is. So here you can see a simple example of that. Here we are taking the, just to understand, we are considering the database of flowers. When we were in chapter 2 or chapter 1, we see something sepal, petal, something like that. And from that data set, we are, for this example, we are considering only the sepal length. This is the name of the column. And we are considering only the sepal width. This is another name of the column. So we are considering only these two columns from that database. And these two columns have values under it. And we are plotting those values are basically the points. And we are plotting those points here, which you are seeing here. And you can see the things like that. These are those values. Points. One value for sepal length, other value per sepal width. Now you have two coordinates like X and Y, huh? And then you are plotting. And here it would be like that. And now you are running your previous algorithm, probabilistic clustering algorithm over it for 3 clusters. For 3 Gaussians means for 3 clusters. You want to form 3 clusters on this data. So that algorithm will run and it will give you the output like that. And this is one cluster. This green is another cluster. This red is another cluster. Normally you have cluster highlighted with the circles or curves. But here the cluster is highlighted with the color, huh? But it is a circle, huh? It is giving you the idea that it is one cluster. It is second cluster. It is third cluster. Anyhow, I hope that you have at least minor introduction of this probability clustering algorithm. Moving next, where we are in the CLO, this clustering type topic is finished. And now we are moving toward the association rule mining. And after that, I can stop if you want. This CO will be finished. Because I have to cover these 2 topics and then etc. Etc. means do not cover anything after that. After that, do not cover anything. I told you that this was not mentioned before. I mentioned these two topics there so that at least there should be some compulsion on the teacher. He must have to cover at least these two topics. And after reading that, there would be some practical. Okay, when we will finish that, I will upload this practical assignment number 2. I already uploaded. If you have seen the Blackboard, I have uploaded all that stuff that would come in future. After that, one is remaining. After this, but after association rule mining, I promised you in the beginning that I will go with the CNN. CNN is an example of deep learning, okay? And you can use it as a supervised and you can use it as a unsupervised. But I promised you at that time that I will run that CNN as a unsupervised technique. So we are in the category, this CLO is covering unsupervised learning techniques. We will cover these first two, but after that, I will go with the CNN at the end. That is the part of these slides. Now, association rules. Now the association rules. If I say I have a association with maybe his name is Abdul Rahman, Abdul Hamid. Okay, I have an association with Abdul Hamid. If I say this, then you will understand that the teacher has some kind of relationship with Abdul Rajiv. Huh? Association means that. Huh? So you will take the same concept here. Association means relationship. And rules, okay, rules is clear. You have to build some rules which can highlight the relationship between two things or more than two things. So this technique, association rule, is normally linked with the distribution sector. Distribution sector means the distribution sector of the industry. If you have for example, Coca-Cola company, then Coca-Cola company has its distributions. They have given their distributions to different persons. And they call them distributors. And they distribute the products to the shops in the market. Huh? So 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 this so now you will understand that this association rule is basically normally used in the distribution sector. So that's why this is a kind of a market-based analysis. This technique is basically for market-based analysis, where you are selling your products, and from your sales data, you can extract different decisions. You can extract different things, and based on those things, you can make different decisions. And those decisions can enhance your business. So then how we can write these rules? So here in association rules, this rule is a kind of a implication. And in mathematics, what is implication? When something implies something, this is called implication in mathematics. Okay. So that's why if you will write something like that, X implies Y, this means this arrow is implies. How I will read that? X implies Y. And how I can understand it in general words, it means if X, then Y. Okay. If X, then Y. In mathematics, how can I read that? X implies Y. And how I can understand it? If X, then Y. This is the meaning of this rule. This is a rule, and this is called implication due to this implies a relationship. So a rule is what? A rule is an implication which will show the relationship between two things. I'm using the simple word two things. Or you can use two sets of articles. These things can be only one thing, or it can be two elements or three elements. It can be set or one article or one product. This X or Y can be one article. One article means one product. Huh? or it can be the set of products, more than one products in one set. So this is not a restriction that you will use this association rule only this distribution sector. You can apply it to any sector. You can apply it to any sector where you want to identify some potential things. Either those things can be products, either those things can be services. For example, here in university, we are giving services. So you can also apply these association rules here in university. Anyhow, so these are some examples to understand these association rules. What is this saying? So I know that what is the meaning of this? If X, then Y. This is the rule written in equation form. And now if I will write this rule in general theoretical form, then for example, this one, if one buys the bread and milk, two products, then he will buy the cheese. So now this is X and this is what? Y. And this is an example of some rule, association rule. And similarly, if one buys a television, then he will buy a VCR. So television is X, VCR is Y. Maybe you will not understand what is this VCR. This is a device of our age. Okay. Yeah, yeah. So anyhow, I don't want to go what is VCR. Leave it. So, but you can understand that this is some kind of a product, huh? So this is X and this is Y. So if you want to, so this is giving you some relationship that the people who are buying bread and milk, they will buy the cheese. And if you will get some if from the sales data you will get this evidence, and then you can make a decision, then you can increase the stock of these things so that you will have your business extended. Okay, moving next. ARM, association rule mining, how we can define it. So now we were going towards the definition of it. So we can define the association rule mining like this. The first thing that we have in this association rule mining, that would be some set I. That would be some set I, capital I. And that I will have I1, I2, and IN. And these small i's, I1, I2, IN, would be what? These would be the set of items in that set of products in that set, okay? And here it is mentioned that it would be represented by binary attributes, which means either I can represent it with 0 or either I can represent it with 1. 0 means this product is absent and 1 means this product is present, you can say. And then you can have your own definitions. For example, you can say some customer has bought this product and then you can write it as 1. Some customer has not bought this product, then you can write it 0, okay? This is what it is saying. And then the second set that this ARM will use, that would be the D, capital D. And this D will contain, this D is like a database, huh? This D is like a database. And this D will contain transactions. T1, T2, and so on, TM. It will contain what? Transactions. T1, T2, TM. It would, and this D is what? It is a set of transactions. And you can call it database. And what is the form of this transaction? These transactions will have the unique transaction ID. Okay, they will have their own ID. That would be the numeric value, but that would be unique, huh? And these transaction can contain a single item or multiple item as a set in it. Okay. What these transaction will contain? These transaction can contain subset of items from the set I, which means that these transactions can contain one item from I or more than one item from I. Now, how I can write this rule? in implication form. So if I have this X implies Y, we already know from the previous slide, I can write this rule in this form, X implies Y. And this X and Y would be what? This X and Y would be the items from the set I. From the set I. It can be one item or it can be more than one item. And what is the meaning of that? Meaning is simple. If X occurs, then Y occurs, which is written here. If X occurs in the data set, then Y will also occur in that. Okay, moving next. So we have seen a little bit definition of the association rule mining, but how we can calculate this? Now the question is how we can calculate this. Uh, so so how we can calculate these association rules, how we can make these association rules first, and then how we can calculate. So we can form or we can make these association rules first by searching your data. That data be the data of your sales. By searching first into the data, you will search for some frequent if and then patterns in the sales data. In the sales data, you will search that if something is bought, then something is bought. You will search these if then patterns in the data. You will search these. And then you will count them, how many times those patterns are existing there. When you will count them, then you will get the frequency of those patterns. Okay. Then you will get the frequency. Again, you can build these association rules by searching your data for the patterns. And what would be the kind of those patterns? That would be if then patterns. X implies Y patterns, okay? And how you can search them? For creation of these association rules, you need two other things. One is support and other is confidence. You need these two things. And these are what? These are again some probability formulas. This support and confidence is what? These are equations. Probability equations. Through these equations, you can calculate something. And when you will calculate something, that will give you the frequency finally. So if you will read this, you can form the association rule by searching the data for frequent if-then patterns, by using support and confidence. Why we use this support and confidence? To define relationships. To define relationships. Anyhow, you can remove this part. You can say we can build the association rules by finding if then else patterns by using support and confidence. This is called association rules. Huh? You can say something like that. But now the question is, what is support and what is confidence? Okay, what is support? In your data, how frequent an item appears, this is called support. For example, if in data, some product 1 is appearing 150 times, that 150 is the frequency, is the value of that support, And the total data is containing maybe 500 items, huh? But the item 1 is appearing how many times? 150. So that 150, according to this definition, this is the count. And support is the probability value actually. So then you will do what? You will divide this to 150 divided by the total number of items in it, divided by 500, and then you will get the support. Anyhow, I will explain it later on, but first get the definition. How frequent an item appears in the data, that is called support. And what is confidence? how many times if then statement, if then statement means X implies Y, huh? So if then pattern, how many times that if then pattern is true? We are not counting it. We are seeing it. How many times this if then pattern X implies Y, how many times that X implies Y is true in the data. When it is true, then you are counting. Then you are counting, okay? And then you will divide with something and then you will get the confidence. There is another thing which is not mentioned here, but it is connected with the association rules, lift. What is this lift? This is again also an equation. This is also an equation which has the name lift. And this equation will calculate what? This lift will calculate your correlation or dependence between item sets or between items. How one item is dependent on another, you can calculate this through this lift equation. You can calculate this relationship, dependency relationship. For example, here you are saying, if someone will buy bread and milk, he will also buy cheese. So dependency. So dependency. So you will calculate this type of dependency through this lift equation. And this dependency also means correlation, which is mentioned here. A and B are correlated. This if A implies B, if it is true, it means that A and B are correlated. And if you have found something in your data that are correlated, and you have found too much evidence of that, and then you can build some decision for your business, and then you can increase the stock of those two things, and then you can have more sales. That is what mentioned here. Moving next. This is just a repetition. You know what is item. I will remove this slide from this because you know what is item. Item, a limited list of items. For example, here, what is I? You know that this I is items, huh? And here it is only example. Items is what? Milk, bread. If you have something like that within the curly brackets, milk, these are the items. And what is transaction? From that previous slide, you know what is transaction. T1, T2, T3, huh? And you know that transaction can contain one item or it can contain more than one items. So, for example, if something is written like that, T1 is equal to milk, cheese, bread. So this is the transaction and it is containing three items in it. Transaction ID is not mentioned here, but you will see in the example. T2, and you have these three items again in it in T2. So what is transaction volume? The number of items in the transaction is called volume. So what is the volume of that? 3. What is the volume of that? 3. If some transaction will have 5 elements, 5. Item set, okay, I can call it item set also. If the T1 is not mentioned, huh? If it said I2 or something like this is not, sorry, this is not. This is a kind of a item set, huh? A set of products, a set of items. So a collection of items occur together. This is called item set. For example, milk and cheese, this is belonging here to T1 and also belonging here to T2. This is general discussion. Now let's start this example first. This is not the proper, but anyhow, let's see that. Understanding this example, we have this data. Here we have bread, milk, cheese, and jam, and the IDs for each transaction is 1, 2, 3, 4, 5, 6. These are the transactions. These are what? The transactions. And what it means in the first transaction, in the sales data, in the first transaction, this is the evidence that when bread is bought, milk is bought, cheese is also bought. And in the first transaction, jam has the evidence 0. Similarly, in 2, bread was bought, milk was not bought, cheese was bought, jam was 0, jam was not bought. And similarly, the reading of all others. So here, So this is just the data that we have, that we collected from the sales data. And now we have to calculate the support of bread, milk, and cheese. We have to calculate the support of bread, milk, and cheese. I told you that what is support. I told you that support is a probability value that you have to calculate. And how you can calculate, the equation is given here. The equation is given here. Support, if you have some rule x implies y, if you have some rule x implies y, then you can calculate the support of that x implies y by using this right hand side. And what this right hand side is saying, probability of x intersection y. Intersection means and. So what is the probability that x and y are coming together in the data set? Okay. What is the probability that x and y were bought together in the data set? You have to calculate that probability. So support is what? It is a probability value, and you can estimate it, you can calculate it by the number of time x and y appear among all the transactions, And this value would be what? Between 0 and 1. It would be what? Between 0 and 1. When you will calculate the value of this support, as it is a probability value, then it would be between 0 and 1. Okay, moving next, we will start this example, but first we are looking at the equations. So then what is confidence? It is again a probability value, and we can calculate this probability value. How? By the frequency of x and y appear together in all the transaction, divided by total number of frequency of x. This is written in sentence form. And now look over here in the equation, then you will understand. Confidence of x implies y. How you can calculate it? So this is equal to probability of y given x. This symbol is called given. So you have to calculate the probability of y. You have to calculate the probability of y given x. And this equation is equal to this thing. Probability of x and y, you have to calculate this, and then you have to divide it with probability of x. That is what written here in these sentences. This equation, only this equation is written here. Frequency of x and y appear together, divided by total frequency in x. So now this equation, probability of x and y, you have seen this probability of x and y. This is something same, So half of the portion of this equation is the support that you have seen previously. This is different. But here we are saying that x and y, when you will calculate this probability, this is equal to support of x and y, that previous equation. So that is equal to that. So something has the probability, and I can call it support of that something. And if here we have the probability of something, so I can also call it support of something by using that same convention. By using that same concept, if I can call it that this is something and this is the probability, and I can convert it into support of that thing, I can also convert this into support of that thing. So now our confidence equation has this form now. Now we will calculate these things literally on the example. So we are supposing that we have an association rule, this, if bread, milk, then cheese. So now this rule is we have in our mind, or this rule is given to us, or being a businessman, we want to find this rule from the sales data, whatever it is. So this rule is now given to you. If bread and milk were bought, then cheese was also bought. So I can represent that this thing is my x, this thing is my y, and then is converted into this implication. And now we have the rule x implies y, in that form. So this rule is basically in that form. So this rule is okay. So this is if then pattern. This is that if then pattern. Huh? Now this is our data. And these are the transactions from 1 to 5, not that previous slide. Here we have removed the jam. Huh? And bread, milk, cheese, and all that other data is same. Now, in the equation, support of x implies y and support of x. We have to calculate these two things for this confidence, And here we are calculating this. Support of x implies y. Because this is our x and this is our y. So support of x implies y. Support of x implies y is equal to what? Probability of x and y. This is according to that equation in the previous slide. So what it means? It means you have to calculate, we have to calculate the probability of x and y together. And according to the definition of support, what it means, how many times this x and y appears in all the transactions. So, okay, x and y, x is what? Bread and milk, and y is what? Cheese. So when you will compare bread, milk, and cheese together, 3 items, huh? So now I will see bread is done, milk is done, cheese is done with the 1. 1 means bought, huh? So if bread and milk is true, if they were bought, cheese is also bought. And here, if bread and milk was bought, cheese is also bought. And in other transaction, it was not that the scene. The scene is not like these yellow ones. So that's why the count is what? 2 divided by total number of transactions, which is 5. And then you will have the value of the support point 4 easy. And now we are going to calculate the confidence of x implies y. So half of the portion is done for this equation. Confidence of x implies y has this equation, probability of y given x, which has this equation further, probability of x and y divided by p of x. This probability of x and y we have already calculated, which is 2 by 5, or you can say 0.4. But probability of x we have to calculate, which is given here. Probability of x, I can write it in a support of x like that. And support of x, how I can calculate? Okay, x is what? X is bread and milk. So now you have to see only the bread and milk. How many times bread and milk is 1? Bread and milk 1. Bread and milk 2. This is not 1, 1, huh? And then here it is not 1, 1. Here it is not 1, 1. So only 2 times. So that's why you have the 2 again. And number of total transaction 5. So that's why the support of x for the bread and milk is again 0.4 or 2 by 5, which you are seeing here. And that is the division between them. When you will divide, you will get the value 1. So this is again between 0 and 1, and this is again value 1. 100% probability, huh? 1 means 100% probability. So how you can say these sentences, how you can say these numerical values in sentences? So if you will look over here, 100% is the confidence. This 1 means confidence value is 1. So 100% is the confidence, and 0.4 means 40% is the support. Now, how I can say something as a fact? So now I am saying 100% of the transactions, 100% of the transactions from these transactions, 100% of the transactions that contain bread and milk will also contain the cheese. Okay. From these transactions, 100% of the transaction that is containing bread and milk also containing cheese. 100%. This is 100%. And you are saying, you are also seeing the situation here. And 40% of the transactions contains 3 items. 40%. So how many transactions, how many percentage of the transactions which is containing bread, milk, and cheese as a bought state? There are only 2, and those 2 is the 40% of these 5 transactions. This is what which is written here in sentence form, nothing else. And how we can say that this is a good rule or this is not? When your rule has the high support and high confidence value, then you can say it is a good rule, otherwise not. And here we have the high confidence, but the support is less than 50%. So then you can say it is something 50-50, just an estimate. So this is not a good rule or something like that. Moving next. Lift. So if you have a rule, you can calculate the lift of that. And what is the equation for the lift? Lift of, if you have this rule A and B, the lift of A and B would be what? Support A union B divided by support of A multiplied by support of B. And you know what is support. And here you don't have the intersection, you have the union. You have the union. When you will calculate the value, if that value is greater than 1, it means positive correlation. If it is equal to 1, it means zero correlation. If it is less than 1, it means negative correlation. And for example, here we have the rule bread milk implies cheese. Then how we can calculate the lift of it? Easy. So first we have to calculate this A union B. So that's why A union B is what? If this is A and if this is B, huh? If this is A and if this is B, then union would be what? Bread, milk, cheese. And now we are going to calculate the support of this A union B. So support of these three items. Now find these three items in the database together. So this is one transaction, this is another transaction, and there is no any other transaction. So 2 by 5, huh? So 2 by 5, then you will have 0.4 again. And the support of bread and milk, when you will count, it would be again. You have to count only bread and milk with one value, huh? And it would be again 2 divided by 5, and you will have this value. And the support of, this is the support of A. A was bread and milk. That's why it is A, huh? This is A. And support of B is what? B is what? The cheese. That's why the support of cheese is cheese. Okay, look at over it. 1, 1, 1, 1, all 5 by 5. 5 is the count and total transaction is also 5. So that's why 5 by 5, you have the 1. Now put these values in this equation and you have finally the value of this lift 1. And what is the meaning of that 1? Indicates zero correlation. It means that there is no correlation between bread and milk and cheese. There is no correlation between this A and B. There is no any dependency. According to this data, there is not any dependency. Okay. According to this data, there is no any dependency between these A and B. Okay. Moving next. What are the different algorithms that you can use for association rule mining? Because these are the equations that you are using. But what are the algorithms? And in those algorithms, these equations are encoded. So these are the three different algorithms. It can be more, but I have mentioned only three. So the first one is a priori algorithm. Second one is FP growth algorithm. And then the ECLAT algorithm. And then the ECLAT algorithm. We will only do this a priori algorithm. We will not do this FP growth. We will not do this ECLAT. You can do it by yourself. But we will get the introduction. We will get at least the introduction, the name, what this algorithm is and what that algorithm can do or something like that. So first the definition of the a priori, then we will in the upcoming slides, we will do that in detail. A priori, what this algorithm can do. This algorithm will, when it will start, it will first identify the frequent item set in your data set. It will look into your data set and then it will find the frequency of the items. After that, when it will find the frequency of single item or maybe double item, maybe three items together, because it is written here item set. We will see. We will see. So first it will identify the frequency. It will count the number of occurrence of each item in the data set. That is called frequency. And then in the next step, it will use this frequency of these item set to generate association rules. And then it will generate association rules. Okay. And in the FP growth algorithm, what will happen? This algorithm will run like a tree structure. It will, the only difference, you will see only difference is that it will run like a tree. So you can say that it will build a tree-like structure. And in that tree is called FP tree. So that's why it is called FP growth algorithm. And that tree, it will, and the nodes of that tree will encode the frequent item sets. So that frequent item is same as here. Same as here. So the nodes will contain the items with its frequency. And then after that, we will generate the association rules like a priori. So then there is no difference except that this has the only tree structure. Huh? So if you will understand this one, you will understand almost all these three, okay? But again, we will only go with the a priori because that is, people are commonly using this a priori algorithm. So we will go with this one. And then eclat. How this word eclat formed. So this is the full form of that. Equivalence class clustering and bottom-up latest traversal. And some letters are collected from it. And then we have the eclat there. And this algorithm is what? It is a top-down version. I'm not saying variation. It is a top-down version of a priori algorithm. Again, a priori algorithm, and it is a top-down. How it is a top-down? Because it will work dividing the items into some equivalent classes. So how you can make, it will divide the items into equivalent classes. And how this algorithm will make these classes based on support. Support is what? Frequency. So it means that it will count the frequency of each items first, and then the items which will have the same frequency, then they will put it in one class, huh? And another class. And then in this way, it can build some equivalent classes, huh? It can build equivalent classes. And when the classes are done, then it can generate the association rules. How? By combining these equivalent classes. So if items have different frequencies, for one item set, or maybe it will have maybe, for example, 100. There is some other item at the end, maybe it has 100. So now you are combining, huh? So these are not complex algorithm. This is simple one. So then you are combining and then you are generating association rules for that in a lattice-like structure. Lattice is called what? This net of the window, huh? Where you have the structure like that. This net of the window where you have the structure, the cube-like structure, huh? And if it would be in three-dimensional, then it will become lattice, huh? Then it will become lattice. So it means then the nodes would be here at this point. It is not a tree like, it is like a lattice. So structure is different. Otherwise, again, it's a priori algorithm, different from a priori, but something like that. At least up to counting for the frequency is same and then structure is different. Okay. Now, what is a priori algorithm? It is now in front of your eyes. The steps are there. Too much theoretical. Don't worry. It is very much simple, okay? But it is lengthy. It is simple, but it is what? Lengthy because it is repetitive. You have to repeat it many times. And then if the question will come in the final exam, it will take your time in repetition. And then the other question will remain unsolved. And then your marks will be deducted. Okay. This can happen. So this is a very tricky question. Huh? This is the only trick that normally teachers have. They will give you some lengthy questions so that you cannot solve the other questions. You cannot solve the other questions. Anyhow, a priori algorithm. Step one. What we will do in the step one, we will build the frequent items that will contain one item, then two items together, then three items together. Basically, you can ignore this step. But this first step is giving you that idea that what we are going to do in the a priori algorithm. So from your data set, what you will do, you will build what? Frequent items. First, you will count the frequency for one item, singletons, and then pairs, two items together, then three pairs, then four pairs, then five pairs, and so on. And here the algorithm is starting basically properly from here. Because in the data sets, first you will have all the points as singletons, all data points as singletons. So now we are going to create the list L1 from the frequent items of size 1. Initially in the data set, you have each point separated, huh? So each point has size 1. So from that size 1, you are going to create the list L1. That list will contain items, frequent items. You so that if some, you can also think further that you can introduce a threshold, and if the count of those items is more than that threshold, then you can consider, otherwise you can remove. That concept is coming, but hold on. So now from size 1, you are creating the first list L1, which will contain the items, as a single entity, huh? Along with its frequency, the count. That count can be the support, that count can be the confidence, because support and confidence is the probability form of the count. Okay, now in step 3, now list 1 is ready. Now from the list 1, you will create a set C2 of two items together, of pairs, okay? C2 of frequent items of size 2, which means now you will keep two items together in this set C2, and you will create this set from the list L1 that you created in the previous step. Okay, now you have the set C2. Now from the set C2, you will create another list L2, which will create again the pairs, but with the frequency. Okay, but with the frequency. L2, you will create it from the C2. And now there is some condition, When you will reach here at L2, now there is a condition. You will keep only those elements in this L2 which will have their support higher than some threshold. You will fix some threshold. For example, if the threshold is 1, and if the value of the support is higher than threshold, then you will keep it, otherwise not. Here support, normally you can say that support is the probability value. How it can be more than 1? Then it means that the number of count, okay? Now in the next step, now list L2 is ready. From L2, you will create another set C3, which will contain three items together, huh? The next step, you will create another set that will contain three items together, triplet. And then from C3, you will create another list L3 from C3. And the condition is same. And the condition is same that if your support is higher than threshold, you will keep those items. But if the support value is less than that threshold, you will remove them. You will remove those elements from this list L3. And You will keep on doing that until your list will become empty. This list, L1, L2, L3, here I am representing it with Li. When this list will appear as an empty list, then your algorithm has to stop. Now, we will run this algorithm over an example. Here, a priori run example, okay. And here we have this item set: bread, milk, cheese, jam, chocolate. First, we are creating our data. Before running the algorithm, we should have some data. Huh? So that's why this is our item set: bread, milk, cheese, jam, chocolate. What we will do, we will give each item a number. As you can see here, bread, milk, cheese, jam, chocolate, and we are giving this number, which is which is these number we will use to identify these items. Okay, to identify these items. And this is your sales data. This is ticket one, means bill one, sales receipt, huh? Sales receipt in which items are mentioned. So in ticket one, bread, cheese, and jam were sold out. And then in ticket three, bread, milk, cheese, chocolate were sold out. In ticket three, bread, milk, cheese, chocolate, and similar concept with ticket four and ticket five. So from this data, and after marking them with numbers, now we are creating our data set. And we are saying that in, for example, if you will see here how the bread is one, okay, the bread is one, cheese is what? Three, the jam is what? Four. So 134, which is mentioned here, 134 is in the ticket. You can say 100. And you have given it also as a ID, transaction ID. And similarly for ticket two, you can give the numbers, and 235 would be something like that, and you can give the number 200. Similarly, for some ticket where you have the five elements, where you have the four elements, this ticket three, this is for the ticket three, and similarly for others. I hope you understood this data, how we are creating this data set. We will now use this data set. We will now use this data set. We will run this a priori algorithm over this data set. Let's see that. Iteration number one of the algorithm. What was the first step? We will create list L1, which will contain single items, and with the count. So here, this is the data set. I just pasted that diagram again. And now here we are creating item set of length one. This was the algorithm, item set of length one. And if you will see into this data set, then you will see how many products you have. 1, 2, 3, 4, 5. I have 5 products, And in the first, and in here in this diagram, we will consider one items each and their frequency. So that's why I am mentioning, this is the column of item set. I'm mentioning the first product, second product, third product, fourth product, fifth product. And these are the numbers. And one can be for the bread, two can be for the milk, And then now you have to calculate the support in this data set. How what is the formula for the support? Count divided by total, So if you have to count this one, how many times one? 1, 2, 3. So 3 divided by what? So here the support is just mentioned 3 because here the count is mentioned, okay? Here we are mentioning only the count, not the probability value, okay? So maybe this label support is giving or misleading you. So you can replace it with the count if you want, okay? The count. Because Support is the probability value. Confidence is the probability value. So you can relabel it if you want. So how many times this one is coming? Three times, which is mentioned. Two is how many times? Three times in the data. Three is how many times in this data? Four times. Four is how many times in this data? Only one time. Only one time. Okay. Now, if we in iteration one, if we suppose that the threshold is one, threshold is two, and all the items with counts, what it means? All the items with count equal to 2 or higher, we will keep those items. But if the value would be less, we will remove it. So this fourth item has less value than this threshold. So we are removing it. And finally, we have this L1, this 1, 2, 3, and 5. These items are left with their values. Now, iteration 2. Generate the list of, generate iteration 2. So that is the same step. That is the same step. Now, how many products are left? One, two, three, four. Now you have to make pairs of all these remaining four items. You have to make all possible pairs. So I can make a pair one with two, one with three, one with five, and then two with three, two with five, and then three with five. So this data set is just repeated, and then you can see these pairs, possible pairs. Okay. From these remaining, fourth is now removed. You don't have to consider four. So these are the pairs. When you have found these pairs, now you have to count one and two. How many times coming together in the data set? One and two. One, only one time. Okay. One and three, how many times? One, here, one and three, two, and here, three times. And this is how we are counting. Okay. And this is how we are counting. And again, now this count is less than the threshold. So we can remove this pair. We can remove this pair. And what are the remaining pairs? Whatever the remaining, so write them here with their counts. This is your L2. This is your L2. And this thing that we done here, this is mentioned in these sentences here. Iteration 3. Iteration 3. Again, I copied the data set again. Now, so now look over these pairs. How many items are remaining? 1, 2, 3, and 5. 4 is not. So from these pairs, I cannot make triplet, huh? So then what? I will focus on these 1, 2, 3, and 5 remaining items. So I will make triplet maybe 1, 2, 3, and 5. And then I will make triplet, possible triplet from these three. For example, I will write them 1, 2, 3, and 5 here. So one triple is this 1, 2, 3. Other is what? You can say 2, 3, 5. Easy, yeah. Other is what? 1, 2, and maybe 5. 1, 2, and 5 is here. Yes, it is here. So in this way, you can make all the possible triplet which are displayed here. So you have to think, huh? You have to think, and you have to make all the possible permutations. We have to now count the support. We have now to count the support. One easy way to count the support is by using that previous approach that you have seen here at iteration 1 and iteration 2. So 1, 2, 3. 1, 2, 3, how many times? 1, 2, 3. 1, 1, 2, 3. No. So it is one time. 1 to 5. So 1 to 5, it is 1 to 5. It is also 1. 1, 3, 5. 1, 3, 5. This is 1, 3, 5. This is true. And 1, 3, 5. This is true. So 2. 235, 235 here true, here not, so 2. So then it has a threshold less than 1, so you can remove them, and then you have only 135 and 235 left, which is mentioned here in L3. This is one method that you already know. The other method is mentioned here. The other method is mentioned here. If someone feels difficulty in making these, in counting these triplets from the data set, then what you can do, you can get the help from those previous pairs that you have calculated here in the previous step. And what you can do, so for example, here, if the we are going to write these triplet, consider these triplets one by one. So 1, 2, 3, writing here. And what are the possible pairs? 1 and 2, 1 and 3, and 2 and 3, which are mentioned here. And then 1, 2, 5. Okay. What are the possible pairs? 1, 2, 1, 5, and 2, 5, which are mentioned here. Similarly for others. Similarly for all these pairs. And now, what pairs which were removed in the previous step? 1 and 2. 1, 2. So these pairs were removed. 1, 2, and 1, 2. And in the triplet where these pairs are removed, you don't need those triplet. And in this way, you will left with the remaining ones. So this is what you are seeing here. And finally here in the list 3. Now, iteration 4. Our list is not empty yet. Our list is still with the items. Huh? When this list will become empty, then we have to stop. This is what the algorithm said. So in iteration 4, I copied the data set again, and now here it was triplet, 3 items. Now iteration 4, we will keep 4 items together. And accidentally we have 4 items left. 1, 2, 3, 5. Huh? How many different items are here? 1, 2, 3, and 5. So that's why we are writing this item set 1, 2, 3, 5 together. And what would be the support? Okay, you can count it directly. 1, 2, 3, 5. 1, 2, 3, 5. This is the only one which has the support 1, and it has the threshold less than 1. Remove it. Remove it. So that's why when in L4 that would be empty, and then you can go out of this algorithm. Huh? But this a priori algorithm is not finished yet. Is not finished yet. So anyhow, you can also calculate in that way, or you can also calculate through by using that previous step. So 1, 2, 3, 5. If this is the if if 1, 2, 3, 5, this is what the item set, write it here and make the triplet. So 1, 2, 3 is one triplet, 2, 3, 5 is another triplet, 1, 2, and 5 is another. Write them all. And what triplet you removed in the previous 1, 2, 3 and 1, 2, 5. So 1, 2, 3 and 1, 2, 5. When this is removed, the whole thing is removed. So that's why it is mentioned that you don't have any support. And in the L4, it is void. Void means empty. You don't have any items left. This was the L3 we copied just to take the reference, nothing else. But this is our latest list. So in the latest list, we don't have any frequent items left. So the algorithm will be finished. Now, what we have to do? Algorithm is finished. Now the actual work will start. Now the actual work will start. Through this algorithm, because you want to build rules, association rules. Those association rules which are frequent in your sales data. You want to identify those rules from the sales data. And when you will identify, only then you will consider those products that you can increase their stock or whatever. Okay. Up to now, algorithm is finished, but we have not identified anything from the data. So we have to identify what? Frequent items. And we have 3 lists up to this point: L1, L2, and L3. So we have to take union of it. We have to take union of it. So L1 is what? These items, which is mentioned here. L2 is what? These pairs, which is also here. L3 is what? These triplets, which is mentioned here. Now take the union. It is mentioned here. You have to take the union of these all lists. L1, L2. By the way, I have not made him subscript. Okay. I have to make it subscript. Okay. So from L1 to, so I have to take the union of these all these sets, and that this L is representing that union. So all items of L1, all items of L2, all items of L3. This is the union. Hmm? This is the union. Okay. We have reached up to the union of this. Now we will construct the rules. Now we will construct the rules. And these lists that we got, these lists are basically representing also their frequency. These lists that we have is representing different items or item set with their frequency. So you can say that these lists are representing frequent items. But now we have to construct rules. And for each frequent set, we can construct the rules how through the when we will set a threshold for the confidence. And when we will set a threshold for the confidence, we are calling it minimum confidence that we want from that data. That we want from data. So we are calling it minimum confidence. And if my threshold is 100%, I want only the 100% items with the 100% confidence. I only want from that frequent list. If you are saying that my minimum confidence is 100%, then what are the items in that union which will have that 100% confidence? You have to identify those. How you can do that? See, the equation of the confidence is conf x implies y. It is equal to probability of x intersection y divided by probability of x. He started closing zips of the bags, huh? This is an indication to me, yeah. Anyhow, so probability of x, I already talked with you in the previous class that either we can continue or either we can have a break. So I am continuing, and maybe I will stop at 7, maybe 30, or maybe before that. So then from the next class, we will take the break for the Maghribah. At what? At 7? And then we will get together again at 7:15. So, okay, take a break and we will start again. So, we were here. Previously, we have taken the union of all of these three lists, L1, L2, L3, and we reached at L. And now we are saying that from this union, we have to identify the frequent items with respect to some threshold for the confidence. And here we are taking the threshold that we will consider only those which will have the 100% confidence minimum. So the equation for the confidence is the same as you have seen on the previous slides. So confidence x implies y is equal to probability of x intersection y and probability of x. This is equal to support of x and y, and this is equal to support of x. So now here we already, for the frequency of single items we already have here, huh? So we want to find the relationships. We want to find the dependency, huh? Dependency of one item on another. So that's why we will not consider single items. So we will start with what? At least with the pairs or the triplets. This is what you have to consider. Single items, there is no relation, huh? Because they are single. So you have to start with the pairs. So that's why here. So whatever pairs you have here, 1, 3, 1, 5, 2, 3, 2, 5, 3, 5. So you are writing all these pairs here. And similarly, whatever triplets you have here, you're writing those triplets here. And we pasted the data set again here if we don't want to go back. So now this is our pair. So this is our pair, which is representing also a rule. And how it is 1 implies 3. How it is 1 implies 3. So this pair, and we want to see something 1 with respect to 3, and also take the reverse. 3 implies 1, all possibilities. Because we have the pair here, this is a subset which has the two items. So then what would be the rule? 1 to 3 or 3 to 1. It has the same meaning. But when you will calculate support and confidence, then at some point their values will be different. Okay. So that's why you are considering all the possibilities. For the support, so when you have 1 and 3 together, so you can get this 1 and 3 to get count of 1 and 3 together from somewhere. This is 1 and 3, 3. Huh? You can, this value is already calculated. You can take it from there, or you can calculate it directly from here if the example is short. Huh? If the example is short, you can take this value. So, for example, 1 and 3. So, 1 and 3 is 3. 1 and 3, here you have that evidence. Here you have that evidence. So, 3. So, 3 divided by total transaction is 5. So, 3 by 5 is now your support. This is the probability which is written in that fraction form. And now confidence. Confidence is, okay, confidence of 1 of 3. So that would be divided by probability of x. That is the equation. That is different from the support. This is the support, but this is probability of x. That is division. Huh? That division is different. Here in support, the division is with the total number of transactions. But in confidence, the division is with the count of x. Anyhow, so this one is the same. This is the support. So you can take the value of support as it is here, or you can count it again. And then probability of x is what? Support of x. And x is what here? X is 1 here. So how many? So 1. Count the number of ones here. 1, 2, 3. So that's why it is 3 by 3. And 3 by 3 is 1, which means 100%. Okay. And now 3 and 1. Now consider the other order in reverse order. So 3 and 1. 3 and 1 is again 3 times divided by 5. The support is same. And then 3 and 1 here, I will get 3. But what would be the value of x? X is different here. Now the x in this rule is 3. So 3, 1, 2, 3, 4. So that's why it is divided by 4, and you are getting 0.75, which is 75%. So this is for the other pair, third, and so you can do for all the pairs. And in all the pairs, and similarly for the triplets, you can see for the triplets 1, 3, 5. So 1, 3, 5. How you can make the rule? So 1 and then 3, 5. So 1 with this 3, 5. And then 3, 5 with 1, the reverse order. And then you can take separate 3 and 1, 5. So all possibilities which you can make from this 1, 3, and 5, we are making it here. 3 and 1, 5, and then their reverse order 1, 5, and 3. And then simply 5 and 1, 3, and their reverse order. And then we are counting. For example, here 1 and 3, 5. So what it means? 1, 3, and 5 together here. 1, 3, and 5. Count them. 1, 3, and 5. Evidence here. Evidence here 2. So that's why 2 divided by total number of transactions, that is the equation for the support. By using that equation, we are writing that value. Similarly, you can calculate for all of it. And now for confidence. So 1, 3, and 5 together, 2. So in most of the cases, support would be same. So 1, 3, and 5 together, 2. But what is x? In confidence, you have this x divided by x. So what is x? X is 1. So what is the count of 1? 3. So that's why 2 divided by 3, 67. And similarly here, 2, 5, and then 2, and here the x is 3 and 5. 3 and 5. This is the evidence. This is the evidence. This is the evidence. So that's why 2 by 3, you are seeing something like that. Similarly here, 1, 5, and 3. I'm just only seeing the confidence. 1, 5, and 3. So 1, 5, and 3. 1, 1, 3, 5. Okay, this is the evidence. This is the evidence. So that's why you are seeing 2 here. And x is 1, 5. So 1, 5. Count 1, 5. 1, 5. 1, 5, 2. 2 divided by 2, 100%. You can count all this like that. And now the minimum threshold that you have set is 100. So that's why you only have to take these transactions only. The remaining, that is not needed because you have set the threshold 100%. So now we are writing. So these are the rules now. Now you have the rules 1 over 3, this one, and this one, this one. These are the 4 rules. How we can write? So rule 1 is 1, 3, 2, 5, this and this. This is written wrongly here, okay? So that's why the red line is already there. You don't have to write it. It is wrong here. Okay, if you will calculate, this is wrong here. So if I will clear the drawing, you will not be able to clear this, okay? This is permanent deleted, huh? So I saved the line here. So this is wrong here. 3, 5, and 1. 3, 5, and 1 is what? 3, 5. This is 3, 5. 3, 5, and 1. 3, 5, and where is 3, 5? This one, huh? 3, 5, and 1, which is 67, not 100%. So this is wrongly typed here or written here. So now these are the 4 rules: R1, R2, R4, R5. And then what is left? R1 is what? 1 is for the bread, 3 is for the cheese. Then the theoretical form of this rule is this: 2 is milk and the 5 is chocolate. So now if milk, then chocolate. Now you can, if bread and chocolate, then cheese. If milk, cheese, then chocolate. Now you have this data from your sales data, which is the rule with the 100% confidence that you should have to consider it for your business. And how you can read them in percentages, that I can say 100% of the transaction that contain bread will contain cheese. I can read them into percentages like that. 100% of the transaction that contain milk will contain chocolate. So this is the reading for all of these 4 transactions. And these transactions are related to which tickets? Almost all tickets, all 5 tickets. So that's why those tickets are mentioned. Those tickets are mentioned. Otherwise, this is not the answer. Answer is these rules that you have identified. So now you have to take care of these products in your stock. You can increase their stock. You don't have to mistakenly lower their stock somehow or accidentally something. You have to take care of these items, huh? So and now this is the source code for this whole a priori. If with the help of a priori, this is the package, okay? A priori. We are implementing the a priori algorithm in order to help the manager in market based answer. This is the lengthy source code. Here we are displaying the data set, which has the lines, how many rows? 7,500 rows. And then we are displaying the data dot shape through that dot shape. And then here we have run our a priori algorithm of that day on that data, and then you have only 11 rules remaining. this is the left hand side of the rule, this is the right hand side of the rule, and this is the support value calculated, confidence calculated, lift calculated. And here now in the next, we are just showing this screen again, but with the order of lift from higher to lower. So, so we are showing all these items with respect to the lift, because lift gives us what? What lift gives us? Their values can be greater than 1, equal to 1, less than 1, positive relation, zero relation, negative relation. So from here you can see the values are almost positive for these all. And this is something rule, huh? Left hand side, right hand side. This is what it means, left hand side, right hand side. Okay, this is now you can see on the blackboard that I have uploaded the practical assignment number 2 for this CLO 2.3 on the blackboard with the deadline. You can see by yourself. I am starting this neural network, not neural network, convolutional neural network. And I will finish it in the next, because it is not small topic that I can finish it in just 15 minutes or 20 minutes. So maybe I can start it in the next lecture. Okay. I don't know. So I don't know. I have to count the slides and then I can answer that I should have.